Good afternoon and welcome to Minit. So here we are in Minit Analyst, which is the tool used by process analysts and consultants in order to drill down into your process data that we are getting from the event logs from information systems. Here we are in the demo project, and we have several processes imported in that demo project with already created analytical views on top of those processes. So each tile is a certain process view, so a state of analysis recorded and saved for the purpose of coming back to this particular results. These are interactive states of the analysis that you can open. Minit also supports collaboration, so other users that I'm sharing this project with are allowed to access the process views created by me, which are public, because I can also have private views, and collaborate on that analysis. It also offers the collaboration in the form of a news feed, so making comments, saving snapshots to the individual views. Importing data into Minit is pretty easy. There is a welcome wizard or import wizard that guides you through that process. So by default, we have some technical connectivity, so you can import file formats like CSV, XS, MXML, Excel, Access files, even in zipped format. You can connect to an SQL Server database, or you can use any ODBC driver that is on the market that you can download or buy from the different vendors of the information systems. We have also prepared ready-made connectors for the most common systems like SAP, Salesforce, ServiceNow for the most common processes, for example, procure to pay or order to cash or ITMS ticketing processes in systems like ServiceNow. Very briefly, just to show you how that works, when we choose to import from the file, let's say we select the CSV, Minit tries to analyze that file, do all the settings, so like delimiter, encoding, qualifiers, and so on for you. Also in the next step where we are actually helping Minit to correct the identified attributes like the case ID, activity, timestamps. As you can see, they are mostly pre-filled or preset for that particular data set. But if something is incorrect or you are not satisfied, you can change that attribute type here in this welcome wizard. Also, you can choose to modify the detected data format. And as you can see also here, Minit also does a data validation. So it validates the data if everything is correct, if the timestamps are not switched, if there are any empty values, you can also set default values and so on. There is a review step, and in the next step, you just name the process and run it with full validation or just with the brief validation, and the process is imported. So the data is imported. When it is imported, it basically creates the process here, and you open the first view. So if we create a new view on top of this process, it immediately discovers the process from the data and shows you what we call a frequential analysis. So the process map with the halo effects showing the most frequent activities in that process, and the thickness of the lines here showing the most frequent path in the process. So as you can see here, we can clearly identify the, let's say, most frequent variation of that process. It shows, the process map shows all the different ways the process took in reality. So it is not it is coming from the objective data set that is from a certain information system or a set of information systems. It is not based on interviews or workshops with the process stakeholders. It just shows all the different paths that were taken by the process. There are many ways to simplify the process map. Of course, you can use a very simple sliders just to come to the most frequent path here, and then by adding the let's say, the activities, we can come to different exceptional behavior in the process and look at how the process gets more complex with not so frequent tasks popping up in the process map. Or use the auto slider settings, which will preset that for you based on the complexity of the process. In some cases, like P2P process on SAP, this is mostly a very complex process with a lot of different edges or paths and activities. Another way to simplify the map is use the clustering possibilities. So we identify the possible clusters and hierarchies. And if we switch that on, for example, the activity cluster here, it will cluster some of the activities into nodes which are expandable or collapsible. So you can see also the information about the number of cases or the performance here is aggregated per cluster. And you can drill down into that particular cluster which is kind of encapsulating some activities only if it's of interest for you. So these are the ways to simplify the map. Let's switch to the plain view of the process map. We can easily switch to performance view. And here we show the mean duration, for example. So we can immediately identify the potential bottlenecks in that process. So here showing the activities that take a lot of time from the processing of the process instance, or the path that are causing some potential bottlenecks. Other metrics that are identifiable are so-called rework metrics. This is a special set of metrics of how the process behaves in connection with rework. So probably the best view, net loop gain here. It will automatically identify not only repeated activities, but also loops in the process where the process is coming back to a certain activity over several other activities. So like larger rework loops. And the red activities identify those which are causing those loops, and the blue ones are the consumers of those loops. So these are the good activities that are taking care of ending the rework loops. So even if we modify the visualization a bit so that we show just the loops that are happening here, you can use this functionality to really very easily, very visually identify the rework as the most frequent inefficiency point in the process. So this is the rework detector. Now, also when you have a financial value, so financial information in the process, in the event log, in the data set, you can import it. We are supporting per resource, so man-hour rates for the resources performing these activities, or fixed costs, or as you can see here, like invoice total amount in the process. So it immediately shows you where the money flows in the process. So what is the distribution? What is the amount of invoices in total going through certain activities or edges? If those metrics, and of course you can get the full context if you click in the map. So the map is fully interactive. You get all the different statistics, like financial here. And also it identifies the top attributes. So we immediately can see the top 5 resources performing this particular activity. And we can already see that one person is taking care of almost 75% of those cases. So there is a little bit of biased distribution toward that person. But you can select any other attribute, look at the performance of these activities from, let's say, city point of view. So what is the distribution over city or the state or cost centers, whatever attributes you have. As you can see, Falkland Islands are pretty much the top in that activity. We are here also identifying variants. So you immediately can see what are the different variations in that process. So you can see that 50% of those cases are just taking the pretty direct path. That's absolutely okay. There's the second variant with almost 30% of the cases having just one exception here, manual entering of the order number, and we can already see this is some potential maybe for robotic process automation, or you can look at different variations in the process and how that behaves. So for example, the first 5 variants are covering 90% of the cases. So in fact, we can focus our analysis of the inefficiencies just to this 5 variants to simplify the process and focus on the most important parts here. Okay, now, but what is more of an interest for us here is that we are able to compare also to, a blueprint of the process. So here, what we want to do, and I just delete this layer here, we have the process as is from the data set from the information system. So this is the reality how the process is happening. Now, in Mega HOPEX, we have a certain blueprint and a description of the process, and we can use that description to compare it to the reality. So what is really happening and how it behaves when compared to that particular blueprint. So what I can do here is add a BPMN layer, and I just select the particular process, and we have it right here. So it's modified, and this is the blueprint in BPMN format. And again, it shows me very nicely the compliance check, how my process is compliant with the particular blueprint. And the blueprint is in green, so we do not see any activities here that would be described in the blueprint in the BPMN diagram, but not happening in reality. But what we see here, there are 2 activities in blue, and this means there are 2 activities which are happening in reality, but they are not depicted in the process description in the blueprint. So we can see that invoice accounting confirmation and demand for information is happening in reality. They are in the logs of the information system from which this process is coming from, but they are not depicted in the BPMN format. Now, what we can do is, of course, the process map is exportable in a BPMN format, so you can get back to the description to HOPEX and then modify it accordingly, or you can use this comparison also, and now switch to performance view. We just see that actually these 2 are just adding a lot of time to the execution of the process. So it's around 5 days here and 2.5 days here for the mean duration of these activities. Now, I want to focus on these activities and to get the root cause of it. So I want to look at which process instances are just passing through those activities. Now, how I do that? Well, I go to filters, and I focus now on the invoice accounting confirmation. So I go to filters and I say, I want to see only the cases where the activity is actually invoice accounting confirmation is inside of those cases. So that's 12 cases, 12% of all the cases. So apply this, and I get a process map which is very similar, but these are only the cases where this accounting confirmation is just happening, and there is no way how to go around it, right? I'm not happy with the outcome. I found out something interesting in the process map, in the different visualization, in the dataset, in the filter dataset. What I can basically do is publish these results, and I will publish it into Minit dashboards. And Minit dashboards are a different type of user interface, more focused on users from the business world. So process stakeholders, process owners, or management, people who want to look at the results of the analysis, and who want to monitor the process. So here we are in my dashboards, by the way, powered by Click engines. underneath, so you get all the different functionalities and power that Click Analytics is giving to Mining dashboards, and on top of that you have visualizations which are very nice, and basically when the process view is published here, there's an application being created, like in this case, and for this particular application you are able to create like this kind of interactive dashboard, so combining the best of business intelligence with the different KPIs and distribution by week and distribution by states and so on with the process map. Right. Okay, so as I said, the process map, now when you come to a process map that is of interest, is exportable in a BPMN format, which is then usable in the modeling world, or to modify the description in MegaHOPEX. Thank you, and let's get back to MegaHOPEX.
Thanks, Michel. So now let's see how we can import the BPMN process. So I'll click on import. Okay, I'm going to look up for the file. Okay. I'm uploading the file. Okay, and then the file is now in HOPEX. Okay, and you can view that the file has been properly imported in HOPEX. We are now going to see how we can improve the invoice approval process through process simulation. In this process, there are two participants, an accounting clerk and an accounting manager. We'll check the effect of moving from one accounting manager to two accounting managers. First of all, let's browse the process. If I click on this activity, I can see this is processed by the accounting clerk and it takes 2 minutes on average. I can change this time as well as the statistic law. I can then describe the office hours that will of course impact my simulation. Let's now check out the key simulation indicators of the process. The process has an average cost of 9.8 euros. It has a certain average processing time and a performing time. Let's now start the simulation, but before that, there are some parameters to adjust. The number of instances and the start date, the input flow. We suppose here that we have an invoice to approve every 5 minutes. We now put the number of accounting managers from 1 to 2. And let's now run the simulation. At this point, it's going to call the Minit simulation engine, and it's now processing. Okay, the simulation ran well. We now have new indicators that have been computed. The process cost is a bit more expensive, but on the other hand, it now takes less time. You can view here the performance time per activity and the utilization time of each resource. This ends the presentation. Thanks very much for your attention.